Have you ever failed inspection, chased a ground fault, or started a panel thinking to yourself like, damn, I should know this? Because if you're still confusing an SLC with a NAC circuit, you're not just mixing up acronyms, you're risking system failure. You're risking other techs laughing at you and your whole entire reputation as a technician. So by the end of this video, I'm gonna clear up all of that confusion. You're gonna learn what an SLC and a NAC circuit is, understand what the differences are, how to apply them in real world experiences, and also how to explain them confidently to your client. So let's get straight into it. Most fire alarm techs learn the SLC or the NAC circuit, how they operate sometimes on a job. You may be working with another technician, shadowing another technician, and he's doing all the work, and all you're doing is watching what he's doing. The next way is what they call sending you to the wolves. You may have been working for about 3 or 4 months, and now they're gonna send you out by yourself. That's a little bit under pressure. So now you're trying to figure out how to actually troubleshoot or even do a regular inspection on his fire alarm system. And lastly, you may have someone watching. It may be a supervisor, so they may have a program to where you are working for about 3 or 4 months, working with another tech, and then they send you out by yourself, and then now that tech who you've been working with is now watching you do the work to see if you actually have the confidence or the know-how to actually troubleshoot the fire alarm system. So just understand, even when I was coming up, no one really explained what the SLC or the NAC circuit was. They just say, hey, these are what the data devices go on, and this is what the horns and strobe circuits go on. I had to learn myself by going deep into the code books and trying to understand what the fire alarm system do, how it performed, and actually how it operates, and what each and every one of these devices are supposed to do. So you never want surface level information. You always want to go as far as you can go, even if you have to pull out a little bit of money to invest in yourself, to either buy these code books, go and take some additional training, whatever it is you have to do to make yourself better in this fire alarm market. That is your job and your responsibility. So let's start with the first principle of how SLC is about communication and not about power. Here's the mindset shift I want you to have for you technicians coming up. The SLC, yes, it does have power depending on whatever system you're working on. Is going to have a different type of power, anywhere between 8, 9, all the way up to 30 volts. You need to understand that this is not current power to drive something. This is just communication power that these devices are actually talking over. It's just like a 2-wire technology with telephone. I pick up the phone and I'm able to talk across these 2 wires. So the smoke detectors, the heat detectors, and all the individual modules have a CPU chipset in it that's actually having a conversation over the SLC data loop, which is the 2 wires that's ran between device to device. Hey, are you okay? Yes, I'm okay. Hey, are you okay? I have a situation, environmental situation. I may be going into alarm. That alarm event will be then transferred over the SLC cable or that SLC data loop to the CPU. It would interpret that as a condition that now I have to turn on the NAC circuits, which is my alarm output. So let's go to the computer real quick so I can show you what a 3 CPU is, and I'm gonna break down all the components inside this 3 CPU. This is more specific to Edwards, of course. And if you want this PDF, you can download it in the description. So right here is the main display of the 3 CPU. You see you have your reset, alarm, panel silence, and drill. Most fire alarm panels, or actually all fire alarm panels, will have a reset button, an alarm silence button, a panel silence button, and a drill button maybe. And then it's also gonna have some menu controls. These alarm, supervisory trouble, monitor, these are LEDs. So whichever event, alarm event, supervisory trouble, or monitor event happens on a fire alarm system, this LED will flash. And you have to hit that check button to acknowledge each and every one in order for this LED to stop flashing. If you just want the panel to stop making noise, because it's beeping, other than the alarm that's activating the horns and strobes, you hit the panel silence button. Now, as we get into the CPU, these are the wiring that you would have to land your data circuits on, and down here is where you would connect your network cable. If you had other nodes or other fire alarm control panels or other annunciators, this is how they would talk over the network. So let's go a little bit deeper into this 3 CPU so we could check out the wiring. If you don't understand, or if you're new to Edwards have a 3-cap 7, a 3-cap 14, and a 3-cap 21. What that means is the 3-cap 7 has 7 slots, 14 has 2 of these bays, 21 will have 3 of these bays, so each bay will have 7 slots. So, but if you have a CPU, the CPU will take up the first 2 slots, and this would start at address number 0. So anytime you see a CPU, this last card will be number 5. If you don't see a CPU, this last card will be number 7. CPU takes up space 00. Card number 1 will be your first loop controller or whatever card you put here first. Card number 1, 2, 3, 4, and 5. And if you have a cap 14, it will start at 6, 7, 8, 9, 10, and so forth and so on. So that's how you actually count the cards if you're looking at an Edwards fire alarm control panel. So at the bottom of the 3 CPU, you have your network connections, where this network connection is how the panels talk back and forth to each other, let them know what devices are there or not. The audio is how we will send audio messages across the network if we had a voice system. So this will be coming in on the B plus, B negative. This would be our network N. This will be going to the next CPU module or the next CPU on the A loop. And this will also be coming from, the B will be coming from. So the panel to the left will be coming in. If we was looking at this on a linear level and this was the first panel going out will be to the right. And if there's any panels to the left, that will be coming in from the outside. Pretty much be a loop for this fire alarm control panel. So you actually have this as a class A coming in and going out. And here's a typical class B network. So the B starts the communication. So from B to A, that will start your communication. If you had a class A, this B will always come back to this A to close that class A loop. Looking at the audio riser, same as the audio starts with the audio out if that's the primary panel. And this is what a particular class A system would look like. It will be going audio out, in, all the way over if you have 3 or more CPUs or control panels, nodes, fire alarm systems, whatever you want to call them. At the bottom of the 3 CPU on the other side of the network connections, you can directly connect your serial cable to upload and download straight from your laptop. You don't have to use the 6-pin connector to plug in. So if you have the 3 cable, the common transmit and receive cables, you could plug straight in and do some terminal assignments straight here from the computer, or you could do the SDU programming as well. And here's the pin out. If you have a DB9 connector, this is what we're using as a DB9. So this will be pin, starting from pin 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3, 5, and 9 will be the pin out for the 3 CPU if you're using a DB9 connector. The 3 will go to the transmit, the 5 will go to the receive, and the common will be the 9. And a good way to test this, this is a pro tip, if you want to test this to see if this actually worked, you can use a little piece of wire or jumper or something like that, short out the transmit and comm while it's plugged into your laptop. You have Notepad open, and if you could actually type on the screen, then that means the cable is working. I know you guys are gonna hit me up like, oh, what you said, how you do that again? That's enough of that. Up top of the 3 CPU, you have 3 onboard relays. Any supervisor in the system, this relay will active, same as the alarm and same as the trouble. So that will be an overall explanation of what an SLC circuit is, and that is your signal line circuit, your data loop, how your communicating devices or your input devices will actually talk over this particular wire. And that would lead me over to my next principle, which is the NAC circuits. I want you to think about this as pure action. Here's the contrast between the two. The SLC loop likes to have a conversation. The NAC circuit likes to perform action. So you need to understand that one talks and the other one performs. So there are 2 very distinctions between the 2 circuits that you're working on, and you cannot confuse the 2, because one landing on the other can disrupt that whole entire circuit and your whole entire fire alarm system. So you don't want to do that. So when an SLC receives an input event like an alarm, the system now interprets that, and the NAC circuit just scream. They scream the horn strobes, they scream the chimes, they scream the bells, or they will actually output some voice enunciation on a speaker if you have speaker strobes on a voice system installed on a fire alarm system. Now, how the NAC circuit is designed, it's designed with an end-of-line resistor. So it's not like the data circuit where each addressable device has its own unique address and they can report specifically what's going on with that particular address. On the NAC circuit, you will have a few horns and strobes on a particular circuit, but if something happens anywhere in between the line, that individual horn strobe on that NAC circuit is not going to be able to let you know that I'm in trouble or that this wire before me is broken. What it will do is the voltage will change, giving you an open circuit if the resistor is broken, if you have a wire broken, or if you have a shorted cable, maybe some construction and there's a screw between a wire, or over time the wire just started losing its resistance over time. Whatever the case may be, however that problem had occurred on the fire alarm system, the NAC circuit will be able to identify, rather it be a short, open, a ground, whatever it is, depending on the change and fluctuation of voltage or the missing and change in resistance. So the NAC circuit can't specifically tell you where the problem is. It's just going to tell you that there is a problem. So now if you're a fire alarm technician who's looking to get better in the fire alarm industry, join my free training center at securisecurities.com/fire alarm training. The link will be in the description. This will get you all the tools you need to get confident to be a better technician out there in the field. There was nobody for me, but I'm trying to be there for you. So let's get back to the video. Now I want to talk about principle number 3, and this is the costly mistake that I see most technicians make out there in the field. There are always different load requirements and device requirements for each particular loop. It is your job to know on that SLC, depending on the type system you're working on, how much current are these devices are going to be drawing, whether it be on an SLC or on a NAC loop, because I know on certain systems, if you overload in a NAC circuit, it's not going to be able to drive the entire output and activate all of the horn strobes. So you would have to be able to do a little bit of math if the math is not already done, but you would have to know how much power can be provided on a NAC circuit, whether it be 3 amp, 5 amps, a half an amp, whatever the requirements are for your particular fire alarm panel. Maybe you have to add additional power to increase the power, or you may have to add an additional loop controller to increase the devices that you may have to add to the system. So it's your job to know what the capacity is that you're actually physically working on currently. Pro tip, if you ever see resistance on a data loop, if the data loop is disconnected, you have a problem. You may have a resistor somewhere on that line, and you need to fix that, because all that's going to do is bring a short to your system, and it's going to knock the whole entire loop out. So if you ever see resistance on a data loop, which you're not supposed to see, it should be an open line, but if you see any type of fluctuation of resistance that look like it's a supervised type resistor on a loop, you have a problem on that SLC circuit, and you need to take care of that. So some things I try to teach technicians coming up when it comes to an SLC or an NAC circuit. The SLC circuit is a conversational aspect of the fire alarm system, and the NAC circuit is the output action of the fire alarm system. This is the guy that's going to react off an input event, rather be an alarm, supervisory, or a trouble event. You can program it to do whatever you want, but usually on an alarm event, it's going to react, it's going to yell, it's going to make some type of noise, enunciation, it's going to let the people know that there's some type of emergency event within this building, and you may need to get up out of here. So remember, SLC is for intelligent devices that can communicate back and forth on a data loop or across 2 pair wires, and the NAC circuits are for non-intelligent devices that need to be told what to do by receiving a power input, so that way it can output the horn, the strobes, or either the voice communication on a fire alarm system. And once your mindset shifts and you start thinking like a fire alarm technician, troubleshooting becomes easy, programming becomes easy, and then actually operating any fire alarm system, no matter what it is, from simplex to firelight, you'll have the confidence to know what you need to do and how to fix that panel when you go on a service call. If this had cleared any confusion up when it came to the SLC or the NAC circuit, I want you to share this with someone who's looking to get into the fire alarm industry. You could click the link in my description, join the free training center. You could also download the EST3 installation module cheat sheet, so that way you can have all the modules and actually how to install each and every one of the modules. And as I close out, I want you to know that confident techs don't just wire systems, they understand them. And by understanding them, it separates you from all the rest. Fire alarm expert out. I'll catch you on my next video, where we're going to be talking about Class A and Class B circuits. Peace.